Alright, it looks like we got this lined up pretty good. At the end here, it gets high. The tip is sticking to the material a little bit, and it looks like it sticks out a little bit. But there for a good, 6 to 8 inches, it's completely straight. All I did was get this caught and just bump it in with the dead blow hammer, just real light, get it lined up. So that ought to do for that. We'll get set up with the tools here and then do a dry run. A dry run is you step through the program, you single block through it, or you just let it run with low feed rate without any tool engagement. So the way we'll do that here is we're actually going to raise the Z 2 inches, because I know I don't go more than 1 inch down into this. In order to cut these slots, I put the 3/8 end mill almost all the way up to the top of the tool, so it's really rigid, and then it can just slot right across here all in one pass after we pre-drill these. So I know I'm only sticking out underneath the part by about 3/4. So if I bring this up to 2 inches, when will be at its lowest point, that should be good. In order to do that, what we'll do is we'll say set the Z at, say, 3 on the digital readout, and then tell the machine that that's actually at 1 inch. So then it will basically just think everything for Z is too low, so it'll run it higher instead. That'll keep us up off the part without any tool engagement. That'll let us go through to make sure we're not going to hit any fixtures. We can eyeball this to make sure our holes all go and slots exactly where we want them to go, and then we can run apart. It's a good way to make sure you don't crash your machine. And since I'm only doing one part here, I really don't care to scrap it and have to rebuild it. And I'm not a production guy. This is just me at home having fun. So I would just soon step through it once, make sure everything's going to be good, and then I can run it and know I'm going to get a good part the first time. Alright, we're getting ready for our dry run. Things you want to do to prepare for that: you turn your regular feed rate down, your spindle RPM way down, and then this bottom one, that's my rapid speed, so I got that turned way down too. I usually have it around 10 or so. Turn on single block. What that does is you hit cycle start. Every time you hit it, it goes through one block of G code, and it'll complete that line, and then it'll pause again. Okay. Turn on your brake. Most cam software puts a brake at every tool change. You can configure that in the cam. I have that on here. And then the other thing that's really handy, if something seems to be getting close to a fixture, a tool, or something like that, you can just hit this feed hold button, and that will stop a line of G code in the middle. But it doesn't stop, it just pauses it. So you can look around, inspect things. If you like what you see, just hit cycle start again, and that line will pick up exactly where it was and finish off. So it just pauses the X, Y, and Z. Well, any of the motion axes. If you have an A or a C or a B in there, it'll pause that too, and then you can just see what's going on and go again. That's really handy. Okay, so we have our Z set. It's offset by 2 inches. I had Z at 9, and then I changed it to 7. So that means Z will be 2 inches too high above the part. So here, we'll go ahead and hit cycle start, and you can see nothing has happened yet. Really, we're just going through. It's picking the tool and setting up all the basic G54 offset that were 1 inch and all that. Okay, now we're going to fire up the spindle, and we're going to start moving. It's actually doing a rapid move down to 0.6. Alright, so let me put you over here so you can see that. Okay, it's moving real slow because I have that rapid turned down. That's safer. Then you know where things are going to go. You won't do that the whole program, but for a lot of it you will. Like here, I know I'm pretty happy with that now. We'll go ahead and get through this first hole here. Okay, so it rapided to 0.2. Now it's going to go ahead and drill the hole. It's going really, really slow because I have the regular feed rate turned down. I can see here that I got plenty of space. I've got my, I'm more than my 2 inches away right now. So I'm just going to turn that regular machine feed up and let it go the way it wants to go because I'm not worried about it. Alright, so the drill cycle's over. Keep hitting cycle start and it's going to move to the next hole. I'm pretty happy with that. I watch a simulation, I know all these holes are going to behave the same. So I'm actually going to turn off my single block. I'm going to turn up my rapid so that this thing can go through and shoot through all these holes. Make sure we're happy with them. So again, what this does is it helps you make sure you're not going to crash your machine. You're going to find out beforehand. You know, imagine if you had a big cutter like this in there. I mean, this is small, really. I mean, think of like a big 4-inch cutter with 10 inserts. You know, $1,000 cutter, a few $100s worth of inserts. That's not something you want to crash and screw up, especially if you only have one of them and then you can't do that job without it. You got to wait for another one. So dry run is a good way to go through your whole program and just make sure you're not going to hit any fixtures and see if you got clearance where you need to go. So I just hit feed hold. So say I didn't like how this was set up, I could get a block in here and say, hey, you know, is the side of this tool holder going to come near this fixture clamp? Obviously I can see it's not here, but if things were close you could do that. You can even come in here. You can't stop the spindle, but you can turn your RPM, at least on this Path Pilot machine. I can turn my RPM to 0. So now my spindle isn't going. It's safe to touch this thing and you know, get a block in here, make sure I have the clearance, or you know, maybe you're just going to use a piece of paper or a little metal ruler or something. That lets you do that. You could just leave the spindle at 0, but I like to have it rotating. I don't know why. I guess it's just a personal preference thing. Alright, so I'm on a feed hold. So I'm just going to hit my cycle start. My feed hold cancels. It was done with the hole, so it was rapiding up anyway. Okay. So now we're going to switch over to our next drill. I'm going to turn the rapid down. Alright, I've got the rapid turned down so I can make sure my approach is good on this one. I see it's going essentially the same place, 0.6, so we should be good. I'm just going to speed that up a little bit. Alright, and there it's cutting the hole. So I'll just give the rapid 100%. I'm pretty sure this will all be fine all the way through here. I have my coolant pump switched off. That's not through the interface. I actually have a hard switch on the side of the machine that just turns the power off to the coolant pump. But the machine thinks it's on. Another thing you can do here in the dry run, if you have fixtures hanging off the edge or something like that, or maybe the part does a little bit, you can make sure you're not going to crash into your ways for the Z back in the back or the cabinet or anything like that. Not get tangled up in your electric lines for the motors or the coolant. Alright, we're on to probably the big drill now, I think. Yes. You always want to turn that rapid down the first time you bring a new tool into the part, especially with drills, because if you entered your offset wrong and it thinks this drill's only 2 inches long instead of say 5 or 6, might just jam that thing right into your part. So that's again one of the things you get from the dry run, is making sure that you've entered all of your tools into the machine right. And since I don't have a tool presetter here, it's all offline. So I'm actually typing the numbers. I could, you know, definitely type one wrong, type a 2 instead of a 7 or something like that, and then I'd crash this tool here. But I'd rather find out at this low RPM and low feed rate, in a dry run, instead of scrapping apart, crashing the machine hard, you know, if this drill was going 2,000 RPM and 10 or 20 inches a minute, maybe it's a mill and you're moving it around fast, you don't want to do that because you're just going to break things. Turn that rapid up. There we go. It's funny, you get into a kind of a zone watching this thing. You don't always remember to turn your rapid up. You can also forget to turn it down again. So you can really screw yourself up if you're not paying attention when you do this. You really got to have your senses keen and pay attention to what you're doing and be thinking ahead when you do your dry run, because you're essentially being the eyes and ears for that machine to see that you don't crash it. Alright, we're going to switch over to our end mill now. We got the rapid turned down again. I'll speed it up a minute here. Alright, slow her down. Says we're going to 0.6 again. Alright, that looks pretty good. Take off single block, we'll let it go. So for this one, I'm going to hit single block again here. We're actually plunging down here so that the top of the surface is almost touching the end of this tool holder. That gets us choked up real good on the tool, so it's really rigid, and I can actually cut this 1/4 inch material all in one pass. So to make sure we're not going to crash, I'm actually going to measure this. So I'm going to turn my RPM down so it's off, so it's safe to get in here. I'm going to go ahead and measure this. Alright, I got 2 1/8, which that end mill is 1 1/8 stick out, so I know that I'm going to have an 1/8 inch clearance in between my tool holder and the face of the part. So that's going to work out real good. So we'll get our RPM back up. And that's what it's going to do. I have the feed rate too high here. Let's go to 100%. There we go. That's the speed it's going to be cutting that slot. Okay, I'm not getting any interference back here. That looks real good. It basically lines up with our little marker marks of what we did, just sketching this out. Looks real good. So I'm going to take single block off, let it run over to the next hole. Alright, I'm slowing down and going back to single block because these holes were modeled in CAM as a separate operation. This is a slotting operation. This is a pocketing operation. It's going to work the same way. It's going to plunge almost all the way down. But since it was different operation in CAM, I had to enter parameters into the tool. So again, there was a human in the loop. I could have screwed it up. So I want to check this one too. Alright, that's our Z. Let's check our depth. Okay, the tool holder is right at 2 1/8. That's what we want. So we should be good to go on this one too. Alright, I'm going to turn off single block because this is doing a turning operate, or it's tracing the side of the hole there. When you get into those, you just can't do single block. It takes too long. You gotta hit cycle start a million times. It's no good. But that looked pretty good. Yep, that's exactly what it's gonna do. 2 more and she's done. Alright, that looked pretty good. Now we can do the real thing. So, I'm going to come over here to my screen, and we're at Z9.8 now. So I'm going to come in here, do a G0, Z7, and let it rapid. There we go. Alright, now I'm going to go in here, I'm going to tell it the Z is now 9. Okay, so that's the opposite of what I did when I went into dry run. I went to 9, I set it to 7. Now it's at 7, I set it to 9. So now it's back to the offset we took when we set up the machine. So it should actually cut this time. Alright, so I gotta figure out where to put you so you can watch this. We're gonna have coolant now. Speaking of which, I'll need to turn that on. So we'll go ahead and run this and see how we do.